do that, you have to first figure out the different components. And I've sort of walked you through it here. So first it says to find the amplitude. Now I'm walking you through it now. There will be a question like this on the final where I'm not going to walk you through it. So you just have to know how to do it. Okay. So to find the amplitude, you go to your curve and you want to slice it down the middle vertically. In this case, this is the center, right? The vertical center. How do you know you've got the center? Well, because this distance from the line that you draw to a valley must be the same as to the peak. Okay? And in this case, it looks like it's a half. So the amplitude is 1/2. Now, the period is the distance between two peaks or two valleys or two zeros. All right? So the vertical line is on the 1, but it goes up 1/2 and it goes down 1/2. Yes, yes. Okay, so for the period, I want to go from one peak to another peak. And on the test, the calibrations are more exact, so you know exactly where it goes. But this looks like it goes 3/4 of the way, right? So this looks like it's 3/4 pi. It goes from 0 to 3/4 of a pi. Like this is pi. It goes to 3/4 pi. So that's the period, 3 pi over 4. Now, from that, I want to write the equation for the cosine function. The equation looks like this in standard form. It's y equals a cosine bx plus c plus d. Okay? Now, a is your amplitude, which is 1/2. B, you can't get it directly from the graph, but you can get it from, you can extract it from the period. So the period, which is 3 pi over 4, is 2 pi over b. Okay? Now, the pi's cancel, so you have 3 over 4 equals 2 over b. You cross multiply, 3b is equal to 8, b is equal to 8 over 3. Okay? That's your b. C deals with a phase shift. In this case, there is no phase shift, so C is 0. D is your vertical shift, and you see that it has shifted how much? This is the tricky part. This is a cosine. It's shifted how much? Down 1/2. Okay? Because remember, this was supposed to start where? Oh, no, it's shifted 1.5. It's shifted 1.5. Yeah, it's shifted 1.5. It was supposed to start at 1. Now it went to -1/2. No, they're independent.
Well, I thought
It can be the same, though.
I thought that you measure it from where it hits the middle.
No, because for the cosine was supposed to look like this. So it was supposed to start at 1. Now it's starting at -1/2. So it's -3 over 2. Okay? That means the equation is y equals 1/2 cosine, sorry, what is this? 8 over 3 x minus 3 over 2. No. No. No, no. No, no. No, no. It's wrong. It's wrong. Man, that 1 cup in the morning isn't doing much. Sorry. Because the amplitude is 1/2, this should have started at 1/2 and gone down to -1/2. So it's just down 1. So the amplitude is a half. Where should this have started? At the half. But now it's starting at negative half. So that's the shift. You can do it through the middle points too. Yeah. Now it's at the half. Exactly. The 0 was supposed to be at 0, but now it's at negative 1. Okay? All right. Yeah.
So like you're looking at it over forever.
I love that I'm teaching this like for 3 classes because I just do this all day long. It's so awesome.
So much fun.
Okay, so we're going to graph cosine, right? So y equals cosine x plus 2 pi. Okay? Now, I take the x plus 2 pi and I'm going to bind it between 0 and 2 pi. When I subtract 2 pi, I get negative 2 pi x 0. Works out perfectly. Okay? So here, this is 0. And then 1, 2, 3, 4. This is negative 2 pi. Now, I'm graphing cosine with an amplitude of 1. That means the first point is going to be at 1, then 0, then negative 1, then 0, then 1. Okay? If you like to make it, cluttered a little bit less, you can do this first and then put in the individual points.
So we need to have 4 points.
Well, 5 total. 1, 2, 3, 4, 5. 4 partitions.
Do we need to have the numbers?
Yes, this is what I'm going to do now. So I was saying,
You can graph it without.
you can graph it without knowing and then go back in and put the points. That's what I was just saying. So now, huh? Oh, because it's cosine, and cosine always starts at y equals 1. So this is the starting point of cosine. Yes, exactly. Okay? So now this is negative pi over, this is just negative pi. This is negative 3 pi over 2. And this is negative pi over 2. So you can do that as well. For tangent and cotangent, because you have asymptotes, you don't. For these ones, yes, because you're graphing cosine, it's totally fine. All right, so now this is the cosine graph. All right, so if you were just drawing a cosine graph, this is how it would look. However, we now have to go in and put in our asymptotes. 1 here, 1 here. And if I were, to ask you for the location of the asymptotes, this is how you get it. It's at negative 3 pi over 2 and pi over 2. It's wherever the graph crosses the x-axis. Okay? So for sine, you're going to hit 3 asymptotes. For cosine, you're going to hit 2. Okay? And now the, what's the other one? The secant looks like this. Make sure to not hit the asymptotes. It's kind of hard on this surface. Okay? And there we go. That's how it looks. Now, I will take away the y-axis for the test, so you'll have, more flexibility where to put it. Yes. Because the asymptotes just go up and down forever. Like they stretch into the sky and down into the... Yes. So if there was a phase, if there was a shift, so suppose the shift is like negative 1, 2, 3, 4, 5, right? You draw a second imaginary axis there, okay? And now suppose the cosine looked like this, okay? Then you're still going to draw your asymptotes where this graph crosses its axis. Do you see what I mean? Okay. All right, so I'm getting good questions now. Questions that, are like at the second level, so that's good. Okay? All right, what else should we do now? We have 5 more minutes. Okay, let me do this one, number 11. I'll do 15.
We just did it.
Didn't we do 15?
We just did it.
Okay, so let me do 11. Let me do 11. We're given amplitude is 5, so that means A equals 5. Period is 3 pi over 2. If period is 3 pi over 2, that just means 2 pi over B is 3 pi over 2, right? That means the pi's cancel. That means we have 4 equals 3B. That means B is equal to 4 over 3, okay? Now, vertical shift 2 means D is equal to negative 2. I'm sorry, positive 2.
Could it be either theoretically?
No, because I've said, then I would have said negative 2. Vertical shift
But I thought
negative
a
2.
vertical shift can't be positive or negative. So it's like
But I will have specified. I will have said vertical shift negative 2. Or down 2 or something. If I just say 2, then it's... Okay, so now here, this is the important part. I've put in assume positive value for B. Because, remember in the homework, what we had done is, like we had said, this could be positive or negative, so then you had to plug it in. I've taken that part away. So just assume that B is positive, and now we put it into the equation. A sine bx plus c plus d, and that means y equals 5 sine 4 over 3x plus 2. Okay? You know, okay, so for number 9, the amplitude is what? Just 3, never negative. That's why I put that negative in front there. Okay, so it's just 3, never with a negative. Because the amplitude is an absolute value. It's a length. It's an absolute value. All right. Never negative. The period is it's 2 pi over B, which is 2 pi over 1 over 2, which is 4 pi. Now, the phase shift, you take the half x plus pi over 5, you set it equal to 0, and you're going to solve. Half x equals negative pi over 5, and you multiply by 2, so x is negative 2 pi over 5. I'll do it again in a minute. Vertical shift is this one, negative 2. Okay?